Hello everyone. Hello everyone. Am I audible? Am I visible? Yes. I can see so many of you are joining in, and yes. Make sure the moment you enter the session, you have to smash the like button. Today we are going to do differentiability. What is differentiability? See, if you go back to the channel, you will realize that we have already done differentiation, the chapter differentiation, also known as methods of differentiation, right? So this chapter we have already done. The next step to it is going to be nothing but differentiability. Okay? All right, everyone. All right, everybody. Okay. So we are going to start on differentiability. Approximately 1.5 hours, we are going to finish everything, including PYQs and concepts. Okay. Today's session is going to be fun, enjoyable also, not a very difficult chapter, I would say. So just be with me, and this 1.5 hour will make sure that you cover all the aspect along with PYQs of differentiability. Now, if you are not aware about me, this is me, your Ninja ma'am. If you're attending my session for the very first time, this is me, your Ninja ma'am, Namrata ma'am. Having a decade of teaching experience, 10 साल हो गए मुझे ऑनलाइन ऑफलाइन में पढ़ाते हुए. ये मेरे क्रेडेंशियल्स है. बंसल क्लासेस कोटा में भी मैंने पढ़ाया है, अगर आप देखो तो. और in fact, so many ninja techniques I am going to teach you on this channel, जिससे आपका सबसे बड़ा मेजर प्रॉब्लम जो है वो सॉल्व हो जाएगा. मैम टाइम नहीं मिलता मैथ्स में, अब तो कैलकुलेटर भी बंद हो गया है ना. तो स्टार्ट करें. आर वी रेडी? रेडी. And make sure that you hit the like button, everybody. I can see Vikash Diamond, I can see Prapti, I can see Tripti Kumari, Gaurav Motivational Live and Life. Okay, are we ready? Just give me a big thumbs up. मैं फर्स्ट टाइम नहीं आई हूँ, आप लोग शायद फर्स्ट टाइम आए होंगे, क्योंकि अभी कुछ दिनों से वन शॉट सेशंस ऑलरेडी चल रहे हैं. रेडी है क्या हम? रेडी. ओके, ओकी डोकी. यस, चलो लेट्स स्टार्ट एंड गो. We are going to finish differentiability. Okay, let's talk about it now. See, if I talk about differentiability now, so please make sure that, please understand one thing, that LCD, limits, continuity and differentiability, I always say that assume that limits is nothing but 9th grade, 9th and 10th and 11th. 3 consecutive classes, you can say 9th, 10th, 11th. Okay, so if at all a student has passed class 9th, okay, then what will happen? If at all a student has passed class 9th, then automatically he will get promoted to class 10th. Now whether he will fail or pass class 10th, that is not 100% confirmed. Okay, and now if he passes class 10th, what happens? He gets promoted to class 11th, but we are not sure whether he will pass class 11th or not. But here is a catch. Understand, if at all a student has failed class 9th, that means limit does not exist. Okay, if limit is not existing, then we are not going to talk about continuity and differentiability. So if at all a student has failed class 9th, you have that information, are you going to ask him that, oh, hello, 9th class fail, what about 10th class? He only will tell you that, are you stupid? I failed class 9th. Now what about class 10th? I don't even talk about class 10th now. I should pass class 9th first to get promoted to class 10th. Okay. And you know what, if a student has, suppose if at all a student has passed class 9th, class 9th is passed, okay, class 9th is passed, that means limit exists. Now he is in class 10th, so continuity may or may not exist. Okay, but now we realize that, oh, class 10th failed, that means continuity is not there. Limits is there, but continuity is not there. then are you going to talk about differentiability? No. If a function is discontinuous, then we are not going to talk about differentiability. Okay, like this is a basic of limits, continuity and differentiability. Basically, the what I'm trying to say is that these are sequential. That's it. If limit is existing, then only we'll talk about continuity. If continuous function is continuous, then only we'll talk about differentiability, like that. Okay. Although a little detailed session, like a detailed concept, I'm going to already tell you that when once we like start studying differentiability now. So I'm going to tell you in detail that what happens when limit does not exist, what happens when continuity is not existing, and what are the scenarios when differentiability is there. Okay, so don't worry, this is just a, like you can say that I have tried to create a story of linking limits, continuity and differentiability. Okay, so that is why these three different chapters sometimes can be considered as one chapter. Okay, now we are going to dive into differentiability first. Okay, let's go into differentiability. So many mosquitoes in my studio. I don't know what happened. Wait, let me fix. Okay, concept of tangent. Okay, so before we understand the differentiability part, let's start from very basic. Let's start understanding the tangent also. So let a function is defined on interval a to b. Okay, so understand. This is your a, this is your b, correct? And now this is your function, and tangent is nothing but limiting case of secant. Tangent is nothing but, this is what? This is nothing but a and b. Can you see this is a secant, or you can also say that this is a chord, right? Now, when AB, the length of AB will tend towards 0, what happen? A and B will coincide, and eventually the figure you are going to see is going to be like this. Okay, can you see that this is going to be A and B, or you can say A slash B. Both points will coincide and this will become a tangent. Okay, so what is a tangent? Limiting case of secant is tangent. Let me write. Limiting case of secant is known as tangent. But ma'am, why are you teaching tangent? Why are you teaching tangent? Because here we want to study differentiability. Now, how come suddenly tangent? Because tangent is closely related to differentiability. So, basics of tangent should be absolutely clear. How come it is related? Now, let's see. Okay. A function is said to be differentiable at point P. A function is said to be differentiable at point P if it has a unique tangent of finite slope at point P. Okay, unique tangent of finite slope at point P. What does that mean, unique tangent? Unique tangent means at one point you can only draw one tangent. You cannot say that at one point, suppose a graph is given and you'll be like, okay, so this is the point, and touching this curve you only have one option. Only one tangent is drawn over here. Can you clearly see? Nobody can come and tell that, oh, I can draw one more tangent. No, so this is not either not this point, or maybe this will not be a tangent. So only unique tangent should be possible. Then only we can say that that function is differentiable. Okay, in other words, a function is differentiable if it does not have a break. Oh, okay, hold on, ma'am. So don't you think that the same condition for continuity? What was the condition of continuity? That the graph should be smooth. So they are trying to say that a function is differentiable if it is continuous. First condition is it should be continuous. Okay. Okay. Alright, now if the function is continuous, then watch out for a sharp corner. If it is continuous but it is having a sharp corner, that will not be differentiable. Why? Why it is not differentiable? Because see, understand, the moment you see sharp corner, what will happen? You will try to draw a tangent on this point, and you will realize that you can actually draw two tangents at this point. One is this and another is this. So at one point, unique tangent you cannot draw. If unique tangent you cannot draw, what does that mean? Non-differentiable. Okay, so basically this you can see is a mathematical definition. Mathematical definition that every point unique tangent should be there. And the second line you are seeing in a is graphical definition. Don't you think that this line is helpful for checking the graphs, that jump or break, that means graphical approach, sharp corner also they are trying to tell that graphical approach. Okay, so first of all, graphical approach let's study, and then we will understand. That what is going to happen. Can you see the first graph? We can see that there is a break. So at C, at x is equals to C, here we are talking about a point only. Okay, at C, the function is actually discontinuous. Hence, so it is what? Tell me, chalo. Now to we know everything. Now limits, continuity, differentiability. Let's talk about that. So limits not exist. Why? Because see, left hand limit, right hand limit, both are different. You can clearly see limit does not exist. Now let's not even go to continuity and differentiability. That means if a student is 9th fail, then we can automatically write na 10th also, like not pass. Not pass means what? Fail only. And differentiability. So if limits is not existing, that means automatically continuity cross and differentiability cross. What about this? Ma'am, here we can see that limit exists. The function is continuous as well. Now understand, we can clearly see that function is continuous. That means for sure limit should be existing. If it is 10th pass, then we can assume that 9th to must have passed. Okay. Visually we can see. But differentiability does not exist. Why? Because of the sharp corner. So this is limit exists, continuous as well, but non-differentiable. Here limit, continuity, differentiability, all three is not existing. Okay. What about this graph? Let's see. So ma'am, we are talking about at x is equals to C. Okay, so this is a sharp corner, you can say. Sharp corner, you can say. So limit exists, continuity is there, but differentiability is not there. Here, can you see? Unique tangent is drawn only. So at C, limit to is there, continuous is there, and differentiability is there. Tell me, are you getting? Are you understanding? Yes? All right. Now, let's actually visualize the concept of differentiability and eventually get the condition of differentiability. Okay, what we are going to do is, this proof is not relevant for JEE Main, but the concept is relevant for JEE, be it Main or Advanced. And you know that sometimes, especially for JEE Advanced, if I talk about, especially for JEE Advanced, your concept should be clear. From where this formula come from, that should be clear. So this slide will be all about that condition, deriving the condition of differentiability, okay, or you can say that first principle of differentiability. Okay, this will be helpful in, the formula will be helpful in class 12th board examination also, not the proof. And once you understand that, then we are going to apply, keep on applying. Okay, so let's derive. So what I'm going to do is, I am going to draw a curve. Okay, and now this curve, okay, this curve has this point A. Okay, A. Now I want to draw two secants. Can you see two secants? This is A, this is B dash, and this is your B. this point is nothing but x is equals to a. Okay, all right, x is equals to a. Now AB is a what? Tell me, ma'am. AB is a secant number 1, and AB dash is also a secant. Okay, this B point, let me mark it as x is equals to a plus h, and B dash will be what? X is equals to a minus h, slightly left and slightly right. Okay, so what you are seeing on the screen is the zoomed version, but this h is very small. So if I try to draw h very near to a, you won't be able to see it. So I have zoomed it, but this length is very small. Okay, very small, very close to 0, almost negligible. But I have zoomed it, zoomed version of this graph, so that you can understand it better. Okay. All right. Now, what is the condition of tangency, by the way? You have studied the definition, right? Unique tangent can be drawn, right? So, unique tangent, how to draw a tangent, by the way? So, ma'am, this secant AB should be 0. Basically, AB tends to 0. AB tends to 0. Okay. So, if AB tends to 0, what will happen? Let me visualize you. That if AB will become 0, then this AB secant will become tangent. Na? So, this point A, now this B will be what? B will coincide with A. So, this tangent line will be looking like this. Right or no? If I move this B slightly, so if I move this line in such a way that secant become tangent, this will become, secant will not cut the curve at 2 points. Now, it will touch the curve at 1 point. And same, this B dash also, if I just remove, so what will happen? This line will be like this. So, this is like this. Okay. So, basically, AB dash and AB will become the same line. So, AB and AB dash both should tend to 0, because see, H is also tend to 0. If H tend to 0, that means this will become close, and this AB and AB dash will become a same line. Right or wrong? AB and AB dash will become a same line. When it will become a same line? Think about it, ma'am. When you make this H absolutely 0. Okay. Alright. So now what does that mean? If they are same line, think about coordinate geometry wise. Think about it, ma'am. If two lines are like representing the same line, their slope should be equal. Right? So that means slope of AB. Tell me slope of AB, ma'am. Slope of AB will be what, ma'am? F of A plus H. See, y2 minus y1, na? y2 minus y1 upon x2 minus x1. y2 means what? Function value at B. F of A plus H, y2. Minus y1, F of A. y2 minus y1 upon A plus H minus A. x2 minus x1. A cancel, okay? So basically this is your and also A anyway cancel. MAB dash, okay? So this is what? Tell me, F of A minus H minus F of A whole upon minus H. Yes or no? Yes. Now MAB and MAB dash should be equals to same, given that H is tending towards 0. Right or wrong? The moment I put H is equals to 0, that means these two lines will become same. So I need to equate the slopes. So let's do that. Limit. Now limit will come into the picture. Limit H tend to 0. F of A plus H minus F of A whole upon H is equals to limit H tend to 0. Okay. F of A minus H minus F of A whole upon minus H. And also understand that in here X is equals to A. Here H is what? H is smallest positive quantity. We are very sure H is not negative. H is positive. So in both the cases H is negative. Sorry, H is positive. Okay, so this we call it as a right hand derivative, and this we call it as a left hand derivative. So right hand derivative and left hand derivative. So this is your right hand derivative and this represent left hand derivative. If these two becomes equal, that means the function is differentiable at that particular point. Are you getting my point? Let's see. See, this is the definition. So the function fx is said to be differentiable or derivable at x is equals to c. Right now they are talking about c. If its right hand derivative is equals to left hand derivative, and that is should be equals to a finite value. What is right hand derivative? F of c plus h minus f of c upon h. Both are h tend to 0 plus. This is also h tend to 0 plus c minus h minus f of c upon minus h. Bolo. Clear? Clear? The formula is clear. How many of you feel that, okay ma'am, formula is clear? Shall I start solving questions now? Yes, first principle of derivative. Yes. Okay. And let me tell you that first principle of derivative, you will feel that, oh, this is only be useful for CBSE boards. Okay. And that is true. 99% chances are there that you won't even use this first principle in JEE Main questions. Okay. But there will be one difficult question, one JEE Advanced question, where first principle will be utilized and your mind will be blown that, oh, so you start studying, because see, all the formulas, all the concepts which you do not use throughout the year, what happens? You just forget it. You just don't, and this is so basic, and JEE Advanced play on basics only. So you forget about basics, JEE Advanced can give you a question on first principle. Okay, and I'm not saying randomly, because we have seen that first principle, a lot of questions from JEE Advanced and some questions in JEE Main. Okay. Comment on the differentiability of function fx at x is equals to 1. Okay, so this is the question, and I am going to tell you 3 methods. Okay, 3 methods to check the differentiability. Okay, so method number 1, first principle method, which we have just learned, that f of at 1, no? So right hand derivative, let's calculate first. So ma'am, limit h tend to 0 plus. H tend to 0 plus f of 1 plus h minus f of 1 upon h. Okay, this is your right hand derivative. Let's see. F of 1 plus h. Okay, so you need a value which is greater than 1. 1 plus h is positive, right? So 2x. Okay, so f of 1 plus h. Can anybody tell me f of 1 plus h will be what? You have to put 1 plus h in place of x. So twice of 1 plus h minus f of 1. F of 1 will be what? 1 plus 1, 2. So that is your 2 whole upon h. Limit h tend to 0 plus. Now 2 and 2 cancel, so 2h. See, 2 plus 2h minus 2 upon h. So 2 cancel, h cancel, so you are getting 2. So right hand derivative is coming out as 2. Okay. Now let's talk about the left hand derivative. Left hand derivative. Left hand derivative. Limit h tend to 0 plus f of 1 minus h minus f of 1 whole upon minus h. Do you remember the formula? Do you remember the formula? F of 1 minus h. H is positive. That means slightly less than s. X less than 1. X less than 1 is here. So 1 minus h. So you have to replace. F of 1 minus h will be 1 minus h whole square plus 1. And what is f of 1? F of 1 is 2 only. So this is your 2 whole upon minus h. Limit h tend to 0 plus. Okay. So this is 1 plus h square minus 2h plus 1 minus 2 whole upon minus h. So 1 plus 1, 2. So cancel. Okay, this cancel. H, if you take common, what will happen? It will be h minus 2 whole upon minus 1. Now the moment you put h is equals to 0, you are going to get 2. That means left hand derivative and right hand derivative are equal. Hence, we can say that function is differentiable. Function is differentiable at x is equals to 1. Final verdict. Okay. This is, you can say that, now understand, you won't use this method when someone is asking you whether the function is differentiable or not. Okay. I mean, you will keep this in mind. If you are stuck, then you can use it. But majority of the time, we are not going to use it. Only for specific functions where we are very confused, where we are not able to differentiate anything. Okay. All right. I'm going to tell you that in what functions we are going to use also. Okay. But we have a shortcut method. This is a lengthy method. You can see that this is a proper lengthy method. We will only use when the other methods will not be like good. We will not be able to find differentiability with other methods. So my priority will not be this method. This will be my last priority, but we'll have to keep in mind. Okay. Now let's talk about method number 2. Method number 2 is graphical method, right? Graphical method. So you draw the graph and that's it. Okay. So 2x for x greater than 1. For x greater than 1, there is 2x. To draw the graph for x greater than 1, 2x will look like this. And x square plus 1 for x less than or equals to 1. If you put 1, you will get 2. So x equals to 1. Oops, not this. This is how the graph will look like. Not like this, but this. Have I done correct? 2x and x square plus 1. Can you see, since the graph is smooth, the tendency of graph is smooth over here. Can you see that this is the tendency? The graph is smooth. So this is differentiable. And can you see that the doubtful point over here is only x is equals to 1. Are you doubting this 2x? Not at all. Are you doubting x square plus 1? Only when the definition is changing then. Okay, so this is method number 2. Method number 3 is, we are going to use this method very often. Okay, so this is your 2x for x greater than 1, x square plus 1, x less than or equals to 1. Very good method. You're going to love this method. Trust me. You just need to differentiate. F dash x is equals to 2x derivative is, ma'am, 2. X greater than 1. X square derivative is 2x. X less than 1. You have to remove the equality. You have to remove the equality. Okay. Don't apply equality when you differentiate. Now tell me. F dash 1 plus. This is going to be your right hand derivative. Tell me f dash 1 plus. F dash 1 plus. You have to find it from here. 2. And f dash 1 minus left hand derivative you can find, which is just 2. So right hand derivative is also 2. Left hand derivative is also 2. So this is the best method. Best method, yes. Okay. So now you know that how to get the differentiability. Let's solve a couple of questions. But before that, let's solve a couple of questions. But before that, let's talk about correlation between continuity, differentiability and limits, right? So we were seeing this when we were studying the beginning part, LCD, 9th, 10th, 11th, okay? So understand, differentiable, if a function is differentiable, if you say that a function is differentiable, that means you are saying that, oh, I have a report card of this student who has passed class 11th, then you'll say, oh, class 11th passed. Are you sure about it? Yes, yes, yes. So you will automatically assume that 10th and 9th will be done. That means limit and continuity will exist. So if a function is differentiable, that directly means that a function is continuous as well, right, at that point. So here if you are able to draw tangent at that point, that means there is no break point, there is not even a sharp corner as well. So that means continuity and differentiability will be there and limits so definitely will be there. Now, a function is continuous. Suppose a function is continuous, that means you are seeing that class 10th pass, the function is 10th pass. You are seeing 10th class report card. Will you for sure say 100% confirmation ke saath you can say that this student, so definitely, even if you say 100 on 100 in class 10th, you can't say that that person is passed in class 11th unless you see the report card. So if a function is continuous, it doesn't 100% means that it is differentiable. You can see the example. The function is continuous, there is no jump, no break, but there is a sharp corner. So continuous is there, but class 11th pass is not there. 10th pass, but 11th fail. Okay. Now, if a function is discontinuous, that means the function is 10th fail. If the function is 10th fail, that automatically gives me that 11th not pass. If a function is 10th fail only, na, it will not get promoted in 11th. How can you say 11th pass? You can't say 11th pass. 11th pass means so it will be 11th fail only. So that cannot, right now the current state is non-differentiable. So a function is discontinuous. Can you see there are breaks? How can you draw a tangent on these points? Right? And if a function is non-differentiable, that means a function is 11th fail. If a function is 11th fail, then can you guarantee say that it is 10th fail also? Not. Okay, a function is 11th fail, that means differentiability is not there. Continuity may or may not exist. So we cannot say that acha non-differentiable. So 10th also must be fail. So that is a presumption. 10th, it can be pass also, it can be fail also. I cannot say. Right now it is 11th fail, but this is 10th pass. If you can see that this function right now is 11th fail, but 10th pass. Okay. And what about this function? This function is 11th fail. We can see that. And we can see that because of 11th fail, not because of 11th fail, but if we check this 10th fail also, and eventually it is 9th fail also. Okay. So let me just curate everything. Differentiability, if a function is differentiable, that definitely means acha. So if the function has 11th pass, so that means 10th pass so will be there. Okay. If a function is continuous 10th pass, so you cannot comment anything about differentiability, you have to check. Okay, so doesn't imply, continuity doesn't imply differentiability. 10th pass doesn't imply 11th pass. That you need to check. Now 10th fail doesn't imply that 10th fail implies. 10th fail implies that okay, 11th also I am now writing fail only. And now if it is 11th fail, okay, doesn't mean that it is 10th fail. Doesn't mean. Maybe the student got passed in class 10th, but now he has failed 11th. It also can happen, no? So what is the conclusion now? All of this. If at all any differentiability, this is so important. And you know what? In this session, let me tell you, you are not going to follow this. You're going to fall in the trap. Okay, I'm warning you. Whenever there is a differentiability question, you have to check continuity first. Okay? Whenever there is a differentiability question, don't check continuity. No. Don't check differentiability. Whenever there is a differentiability question, don't check differentiability first. Check continuity first. If at all the function is discontinuous, then you don't even need anything. Will you check differentiability? Tell me. Okay? Right? Chalo. Let's see. The graph is a bit inaccurate. Which graph are you talking about? This one? 2x. 2x. So and x square plus 1. Have I done anything wrong in this? 2 is the x square plus 1. X square, x. Yes, graph is slightly incorrect. This is the graph and this is the graph. This is x square plus 1. No? This is the graph. Okay. Chalo. Now let's solve this question. Do you want to solve it? Acha, which method are you going to try? Which method? Method 1, method 2, method 3, first principle, graphical method, and the second one is method number 3 is that shortcut, my favorite method. Okay, so which method are you going to apply and tell me the differentiability? I am right here. Apply and let me know. Solve it, solve it. All right, so if method 3 you are going to apply, then f dash x, tell me, 2 e power 2x and this is 2 cos x less than 0, x greater than 0. Okay? All right, now tell me, f dash 0 plus, that means right hand derivative. is what? 2. F dash 0 minus is 2 left hand derivative. Then what can we say? What can we say? Can I say that function is differentiable? Can I say that function is differentiable? Not really. The function is non-differentiable. But ma'am, how come non-differentiable? How come non-differentiable? Oops. What just happened? This is a trap. Okay? Because I told you, before checking differentiability, you don't even have to do this. First of all, check continuity at x equals to. Check continuity. F of 0, tell me. So, ma'am, f of 0 will be e power 0. So, that is 1. F of 0 plus. So, 2 multiply sine 0 plus. Sine 0 is 0. So, this is 0. The function is discontinuous at x equals to 0. That implies the function is non-differentiable as well at x equals to 0. You don't have to check it. Okay? Yes. So, that's the agenda. That's the core concept which I am trying to tell you. Now quickly, one by one, we are going to solve problems. Let's do that quickly. Okay. Check differentiability at x equals to 1. Let's check together. F of 1, tell me. Ma'am, f of 1. First of all, continuity we are checking. F of 1 is, ma'am, fractional part of 1 plus 1. So, this is 2. F of 1 plus will be what? Fractional part of 1 plus 1. So, ma'am, fractional part of 1 plus. 1 plus, that means 1.000 something. So, fractional part of, sorry. This is not, fractional part of 1 is 0 plus 1. So, that is 1, right? This is also 0. Fractional part is hardly like anything. So, 0 plus 1, this is also 1. Now, f of 1 minus will be slightly different, maybe slightly different. 1 minus, so 1 minus, if you put it over here, it will be approximately 1. And this is what? If you put 1 minus, so this is 2 minus, slightly less than 2. Okay, so this is what? Tell me 1 plus 1. So this is 2. Discontinuous. Can you see the function is discontinuous at x equals to 1? Hence, it is non-differentiable at x is equals to 1. Okay. Yes. So this question also done. Now understand a little concept. Differentiability in an interval. Okay. Differentiability in an interval. So, differentiability in an interval says two things. So, suppose in an interval a comma b. So, in an interval a comma b, open interval a comma b. So, I think it is very obvious that at every point the function should be differentiable. That's it. There is no theory related to that. So, at every point the function should be differentiable at close interval. But now, if you are talking about the, open interval, that means between a and b at every point it should be differentiable. Now, but if you are talking about the close interval, so for close interval, what we will do is, number 1, open interval mein to it should be differentiable. But ma'am, what about x is equals to a and x is equals to b? So just understand that for x is equals to a, only right hand derivative should just exist. Only right hand derivative should just exist. It should not be equal to anything. Right hand derivative should just exist finitely. And for x is equals to b, your left hand derivative should just exist. That limit should exist. Whatever value should be finite. That's it. Okay? Like that. Now, when exactly are you going to, like, suppose I have given you an interval. So it is so obvious, just like we studied in continuity. Are you going to check each and every point? It is not possible. So what will you do? Tell me. If at all A function is given and now you have to check the differentiability everywhere. Big interval is given. So now, obviously, again, the concept of doubtful points will come into the picture. So at points where continuity is to be checked. So differentiability, if the question of differentiability is given, so whatever the concept of continuity was there, now we were studying that, okay, when exactly do you check the continuity? So if GIF of fx is given, so you check where fx is becoming an integer. Fractional part of fx is given, okay, so you check fx is again an integer. Doubtful point, same. So doubtful point of continuity is same as doubtful point of differentiability, plus one more additional thing I am going to tell you, but right now let me just list all the continuity. Signum of fx, tell me. So you check when fx is equals to 0. Okay, so think like this is a continuity question only. Okay, and now one more point we will check. So suppose mod of fx is there, modulus is there. In continuity, remember in last class we have studied, if at all a function fx is continuous, then mod fx will also be continuous. No need to check. Yes or no? Agree? But in differentiability, if fx is rock solid, if your function fx is differentiable, continuous, something, absolutely fine, fx is there, but mod fx, so mod fx will be continuous, but you need to check the differentiability when fx is equals to 0. So this is one additional point you have to check. This is one doubtful point. So whenever you see modulus and you see continuity question, don't need to worry about if your function inside the modulus is fine. But if your function inside the modulus is given, and that is fine also, but differentiability question is there. So in case of differentiability, now modulus play an important role. Why? Why modulus play an important role? Because you see, whenever I take modulus, now suppose this is line, I take modulus, it will become a V-shaped graph. So there are chances of getting a sharp corner, which is important for differentiability. Sharp corner is important. Whenever there is a sharp corner, function is non-differentiable, but whenever there is a sharp corner, function is continuous, still continuous. So that's why modulus and continuity is there, no need to worry. If the function inside is okay, then you are okay. Modulus is not bothering you. Function can bother you. Modulus is not. But modulus can bother you if the differentiability is there. Don't worry. You might be thinking that what ma'am is saying, but we'll solve problems, then we'll know. Okay. So comment on differentiability of fx is equals to mod of x minus 1. Now again, they have not given. Have they given any point? Till now, they were giving, check the continuity differentiability at x equals to 1, x equals to 0. Right now, they have just given. Now, we need to think, okay, at what point shall I check? So, at what point modulus of x minus 1? So, I told you x minus 1 is equals to 0 is my doubtful point. We need to check just at x is equals to 1. So, again, 3 methods, okay. So, let me just x minus 1 and this is 1 minus x. Open the condition of modulus. And this is x less than 0. Okay. So now method number 3, if I check f dash x is equals to 1 and this is minus 1. Can you see? For x greater than 0, for x less than 0. So can you see? Non-differentiable it is coming. And even if you draw the graph, method number 2, graphical, mod of x minus 1. So this is 1. And this is how it is. Okay. So that's why it is non-differentiable. Are you getting my point? Comment on differentiability again. Now graph will come into the picture. So this is a parabola x square minus 3x plus 2. 1 and 2 are the roots of this. And can you see this, that this is how it is? And yes, now can you see this? So this is sharp corner 1, sharp corner 2. Non-differentiable at x is equals to 1, 2. Now tell me about mod log x. Okay, so log x, graph of log x looks like this. If you take mod, you know how to take mod. You have to remove this portion which is below x-axis and take the mirror image. So this is how it will look, and hence you are going to get a sharp corner. So non-differentiable at x is equals to 1. Rest everywhere it looks differentiable. Non-differentiable at x is equals to 1. Okay. All right. Now understand. Theorems on differentiability. If two functions are differentiable, fx and gx are differentiable, then their sum, product and division will be differentiable. Okay. And if one function is differentiable and one function is non-differentiable, then their sum, product, so their sum will be non-differentiable, and rest anything we cannot say. And if you have fx and gx both non-differentiable now, so we cannot say about anything. This is the table. Okay, not very difficult to remember. If both functions are differentiable, then sum, product, division differentiable. If one is differentiable, one is non-differentiable, then sum will definitely be non-differentiable. Subtraction will definitely be non-differentiable. Baki, we can't talk about product, we can't talk about division, and if both are non-differentiable, we can't talk about anything. We can't talk about anything. Okay. Now, there are one more type of questions that you might see, and that is going to be minimum and maximum. Okay, very good type of a question. JEE Main actually gives such type of question as well. You will see that maximum of two functions. Okay, so this can only be done by graphical approach. So they will give you fx and they will write min or max, whatever they want to write, min of sine and cos. So these two functions you have to plot in the same curve. Okay. So these two functions you have to plot in the same curve. So sin x will look like this. Can you see? And minus pi to pi. So make sure that you are plotting in the interval only. And cos x. How does cos x look like? So cos x look like this. This is minus pi, this is plus pi. Now minimum, you have to talk about the minimum, right? So minimum. So whatever graph will be the below one, competition is there. Okay, minimum of these, competition is going on. So whatever is below, that will be my graph. Now can you see, I will divide this whole graph into portions. Can you see this? Then they are meeting over here. Then eventually they are meeting over here. Okay. So first, I can see, ma'am, pink graph. Pink graph is below. So this will be my graph. Now after this, after they meet, my blue graph is below and pink is above. So I will only pick below graph. Can you see, this is my below graph. This is still below, blue below pink, blue below pink, blue below pink, blue below pink, blue below pink. And now the situation changes. Can you see, blue becomes above but pink becomes below. So pink is below. So I will only talk about the below graph. So can you see, all the yellow part is my graph. So if you try to draw now, just see this. This is my graph. This is my graph. Can you see the yellow part? That's my graph. Now what we need to know is, now I think once the graph is plotted, you can see sharp corners, you can see continuity breaks, everything. So can you see one sharp corner you can see here, another is here. So this is x is equals to what? Tell me. So this is minus 3 pi by 4. And what about this? X is equals to pi by 4. So 2 points, non-differentiability. at x equals to pi by 4 and minus 3 pi by 4. Agree? Yes, everybody? Chalo, let's do one question. Let's do one question. Okay, let's see, let's check. So again, minimum of sin x and cos x. Okay, so S is a subset of, now understand this question. Understand this question. S is this the question is done right now, we have done now. S is subset of which of the following? So any set which is having two elements, pi by 4 minus 3 pi by 4 will be my set. So here ma'am, minus 3 pi by 4 is there, option A might be correct. Let's check, but so only 3 pi by 4 is there. Only pi by 4 is there. Only pi by 4 is there. So only option A is that option which is having all the things together. Okay, all right. Now the next question on your screen. Next question. So you need to plot this. Let's do it together. Fx mod x less than or equals to 2 and x is mod x lying between 2 to 4. First of all, understand, this is a symmetric graph. Oops, I think I need more space. So what should I do? See, understand. Let's draw this graph nicely. So what will happen first of all? Mod x less than or equals to 2, right? Mod x less than or equals to 2. Can you see that first of all, this graph is an even function? How many of you have noticed? This is an even function. Mod x, x square mod x. Even if you replace x by minus x, the function will be changed or not? If you replace x by minus x, the whole function will be exactly ditto same. So f of minus x is fx. That means even function. Even functions are symmetric about y-axis. So what we need to do is we just need to plot the right hand side of the graph. Okay. So till when we need to plot x less than 2? So 0. We'll start with 0. Then 1. Then this is 2. This is 3. And this is 4. 1, 2, 3 and 4. Okay. So now x less than or equals to 2, you have mod x and x square. So you need to plot both the curves. Okay, mod x between this. So mod x is actually x, right? So this is your x. And what about x square? So at x is equals to 2, you are going to get 4. So your graph will look like this. One pay will get the same value, no? This is how your graph will look like. Yes or no? Now, so this is your x square. This is your x square. And this is your mod x. Or y is equals to x for that matter. Okay, but now understand, we need to plot the maximum. Think about plotting the maximum. I need to erase this. Okay, maximum. So maximum will be like this. Maximum, that means we need to pick. We need to pick which is above. Okay, so can you see this is the graph which is above? Above will win, no? This is maximum. And now blue one is the maximum. Can you see this is the graph? So this white one is my main graph. And we can see there is a sharp corner at x equals to 1. Okay. After that, what will happen? 8 minus 2x. So we need to plot 8 minus 2x between 2 and 4 now. So if I put x is equals to 2, what do I get, ma'am? 8 minus 2, 2s are 4. So 4 only you are going to get, and this is 4 only. So graph starts from here. And if you put x is equals to 3, you are going to get 2. So 2 is here. And if you put 4, you are going to get a 0. So this is a straight line which looks like this. So the white color graph which you are seeing is your original graph. And if you want to plot, although it is not required, but just in case you want to plot, and let me just increase. So this is your this is the graph. The yellow color graph, no? This, then this. Okay. This is thodi curvy. This is not a straight line. This is a curvy. And this. So on the right hand side and the left hand side, if you want to plot, it will look like this. Then it will look like this. It will come down. Symmetry. So can you see that there is one sharp corner, second sharp corner? This is also a sharp corner. So how many sharp corners, tell me? Ma'am, x is equals to 0, comma, plus minus 1, comma, plus minus 2. Okay, so 0, plus minus 1, plus minus 2. Option A is absolutely correct. Option A, right? F is non-differentiable. What happened, Nitin? Okay. Option A is correct. See, this is how the graph will look like. You can see. Okay. 1, 2, 3, 4, 5. Option A. Yes. Now let's do a couple of questions. Okay. Let's do a couple of questions based on differentiability. So I think the concept wise we are almost done with everything. Chalo. Basic questions quickly. These type of questions actually will be, you might see in JEE Main. So yes, let's do it. This is the question. Do you want, this is the question, right? Now fx is this, and for x less than 1 and for x greater than 1 it is this. They are giving that it's differentiable. It is given that it is differentiable at x equals to 1. Differentiable at x equals to 1. Okay. So now, how to do it? Because if it is differentiable at x equals to 1, so obviously f dash x is equals to what? Derivative of a is 0 plus 2bx for x less than 1. And this is 3a, that's it. Minus b plus 2 will be 0 for x greater than 1. Not equals to, don't apply equals to, otherwise it will be wrong. Okay, so now for 1 it is differentiable. So put 1, left hand derivative should be equals to right. So f dash 1 plus should be equals to f dash 1 minus left hand derivative, right hand derivative will be equal. So now 2b into 1 and this is equals to 3a, first thing. But ma'am, only one equation we are getting. How to get the second equation? How to get the second equation? If this is differentiable, then it would be continuous, right? So I will get one equation by making this function continuous at x equals to 1. That means f of 1 should be equals to f of 1 minus. What is f of 1? Tell me, ma'am. 3a minus b plus 2 is equals to f of 1 minus, which is a plus b. So two equations, two unknown. Can you solve it? Tell me. So this is 2a minus 2b plus 2 is equals to 0. So a minus b is equals to minus 1. A is equals to b minus 1. A is equals to b minus 1. Okay. So this is what? B is equals to 3. B is 3. And the moment your b is 3, your a will be what? Moment your b is 3, a will be 2. So 2 comma 3, yes. I think 2 comma 3 is sitting in option D. Yes? Everybody? 2 comma 3. See what we did. Fx is differentiable. So we realize that 2b is equals to 3a. And if fx is continuous, condition of continuity says this. Now if you solve these two equations, a is equals to 2, b is equals to 3. So 2 comma 3 will be absolutely right. Okay. Yes. Clear? Now one more question. One more question. Comment on derivative of fx. Oops. So sometimes, now in such questions, can you see sometimes x is equals to 0, it will become 1 by 0 tan inverse infinity. Sometimes your method 3 will not work. And how can you plot the graph of x into tan inverse 1 by x? In such question, first principle will come into the picture. So let's do it with first principle, right? So first principle is what? RHD you need to calculate. So f of 0 plus h minus f of 0 upon h. Limit h tend to 0 plus. So this is f of h tan inverse 1 upon h minus 0. Okay. So now h cancel. Tan inverse 1 by h. Tan inverse infinity is pi by 2. Okay. Left hand derivative. F of minus h upon minus h. Limit h tend to 0 plus. Because we know that f of 0 is anyway 0. So directly I am doing it. Yes. F of minus h. So it is going to be what? Minus h tan inverse minus 1 by h. So it will be plus upon minus h. H cancels. So this is going to be minus of tan inverse 1 upon h. So can you see this is coming out as minus pi by 2. So hence it is non-differentiable at x equals to 0. Yes? Getting it? Chalo. This question. And I want all of you to solve it. So again, first principle will come into the picture. Can you see now? Can you see the pattern? Why I am going to apply first principle? The moment you see 1 by 0 kind of a thing, then your first principle will be applicable. Okay. So now right hand derivative. Tell me. First of all, continuity they are talking about now. So first of all, so I need to talk about continuity in this, right? So if you put 0, what will happen? F of 0 is 0. Okay. Now limit x tend to 0 will be what? X 3 e power 1 by x plus 4 upon 2 minus e power 1 by x. So the moment you put 0, it is going to be e power infinity. So this is going to be infinity and this is also going to be infinity, right? So understand that this is becoming infinity by infinity form. So what we will do is, we'll take the maximum infinity common. E power 1 by x I am going to take common from both. So x 3 plus 4 e power minus 1 by x, and this is 2 e power minus 1 by x minus 1. Now you put x tend to 0. So this is your 0. 0. Now what about this? E power minus 1 upon 0. See, understand. E power minus 1 upon x will be what? Ma'am, 1 upon e power 1 by x. Now if you put 0, ma'am, 1 upon e power 1 by 0, 1 upon e power infinity, 1 upon infinity, 0. So e power minus 1 by x is becoming 0. So these two are becoming 0. So 0 multiply 3 upon minus 1, so 0. So that means limit value is coming out as 0. Function is actually continuous if you observe. So function is continuous. Option C is wrong. And in fact, option D is also wrong. Because see, now the function is continuous at x equals to 0. Now it may or may not be differentiable. So either A or B will be correct. Either it will be differentiable or non-differentiable. For that, left hand and right hand limit. So right hand derivative, let's calculate. So limit h tend to 0 plus and f of h minus f of 0. F of 0 is 0. So f of h upon h. So this is h 3 e power 1 by h plus 4 upon h. H is there, and 2 e power 2 minus e power 1 by h. H cancel. And again infinity by infinity form. The moment you take e power 1 by h common from both the sides, I am removing it. What will you get? Tell me. What will you get? So e power 1 by h. So 3 plus 4 e power minus 1 by h and 2 e power minus 1 by h minus 1. So this is gone, this is gone. So answer will be what? Minus 3. Minus 3. Right hand derivative is coming out as minus 3. Correct? What about left hand derivative? Left hand derivative. So left hand derivative, let's do it here. LHD. LHD will be limit h tend to 0 plus f of minus h upon minus h. So f of minus h, correct? So minus h 3 e power minus 1 by h plus 4 upon 2 minus e power minus 1 by h, and this is minus h. Minus h completely cancel. Now this time automatically e power minus 1 by h got created. You don't have to take common. Why? Because this is automatically becoming 0. See, h tend to 0. So the moment you put e power minus 1 by, so this is 0, this is 0. So answer will be what? 4 upon 2. That's it. So 2 is the answer. So clearly left hand derivative is 2, right hand derivative is minus 3. So continuous but not differentiable. Option B. Okay. Correct, everybody? Now, one more important point I would like to make, that whenever inverse trigonometric functions are involved, no, check differentiability at boundary points of the domain. Okay. So let me tell you why. Suppose fx is equals to sine inverse x. Do you remember the graph of sine inverse x, by the way? Because I have taught you this. Sine x graph is this. So sine inverse x graph looks like this. Yes or no? And at this is your pi by 2. Can you see at pi by 2 boundary points you are drawing a vertical tangent? Oops. What is vertical tangent? Okay. So now let me tell you that there are some functions which looks that, oh, suppose y is equals to, this is the graph, suppose this. Tell me, graphically check, at x equals to 0, is the function differentiable? So you will say, yes ma'am, function is differentiable because there is no jump, there is no break, there is no sharp corner, so it looks differentiable. But can you see at x equals to 0, you are drawing a vertical tangent. And vertical tangent means what? The slope is infinite. And as per the definition, that a unique tangent has to be drawn of finite slope. So that's why if at all vertical tangent comes into the picture, the function is still non-differentiable. That means one more thing got added. We were actually looking for sharp corner, but if at all you find that at any point you are able to draw a vertical tangent, it looks like it is smooth, it looks like no sharp corner, but in reality, as per the definition, mathematically, that function is non-differentiable at that point. Okay. Same goes with this at x equals to pi by 2. You need to check differentiability. Now, because pi by 2, after pi by 2, we don't have anything. So I told you now how to check differentiability at boundary points. So LHD at x is equals to pi by 2 should exist. If it is existing, that means that is differentiable. So LHD will be what? F of pi by 2 minus h minus f of pi by 2 upon LHD will be minus h, limit h tend to 0 plus. Let's check it out. 0 plus. Okay. So sine inverse. Sorry, pi by 2. Not pi by 2, actually 1. No, this is 1. Sorry. 1. 1, 1, 1. Not pi by 2. This is x equals to 1. The value is pi by 2. Okay, so LHD at x equals to 1. Not pi by 2. Boundary point is what? 1. So 1 minus h minus f of 1. So sine inverse 1 minus h minus sine inverse 1 is pi by 2 whole upon minus h. Can you see 0 by 0 form? Oops, sine inverse 1 by 1 minus h. Oops, yes. Now do you remember that point? Pi by 2 minus sine inverse x. I am going to apply that formula. Sine inverse x plus cos inverse x is what? Pi by 2. So pi by 2, if you take so this is actually pi by 2 minus sine inverse 1 by 1 minus h and upon h. So this is actually cos inverse 1 minus h upon h. H is 0. The moment you put 0, cos inverse 1. Cos inverse 1 is what? Cos theta is equals to 1 at 0 degrees. So this is 0. 0 by 0 only we are getting, no? So cos inverse 1 minus h upon h. How to tackle it? Let me tell you. See. This is what we are getting. Now here again 0 by 0 form is getting formed. So what to do now? Either you know the differentiation of cos inverse, you can apply that, but now what I am going to do is I am going to convert this. So 1 minus h I am going to put as cos theta. So that inverse thing vanish. Okay. Or you can say that this becomes a theta. Put this as theta. So what will happen, tell me? So cos theta is going to be 1 minus h. Okay. So h will be what? H is 1 minus cos theta. So now convert this. This is going to be theta. See, this is your theta and h is 1 minus cos theta. So now theta tends to 0. Theta tends to 0 because the moment you put h is equals to 0, no? Your cos theta becomes 1, so theta is equals to 0. That's why the limit got changed. Substitution method. Theta becomes 0. So theta upon 1 minus cos theta. Okay. So this is theta upon 2 sine square theta by 2 will be there. Okay. Now what do you want? This is going to give you what? You need 1 theta and 1 theta. You need by 2 and you need to multiply 4. Okay. So this is going to be, not this. This is going to be 1. Sine 0 by 0, remember? And eventually 4 by 2. So this is 2 by theta. Theta tends to 0. So 2 by 0 is infinity. That means it is non-differentiable. It is non-differentiable. At x equals to 1, it is non-differentiable. Right? So for inverse trigonometric function, we need to check the differentiability at their boundary points. And if at all the direct function is coming, a sine inverse x, tan inverse x, draw the graph. Find out whether there is a vertical tangent. See, I have told you all the 6 graphs of inverse trigonometric function. Right? So just draw the graph now. Why to do this? But if at all sine inverse some random, inside some random function is there, sine inverse 1 minus x. Now check. X times sine inverse x. Now you have to then check. Okay. Alright. Now one last question. One last question I will give you. Let's see how many of you can solve it, because this is a absolutely like template category. These type of questions you might see in JEE Main PYQs. And we are done with differentiability. So again, differentiability. So I told you whenever differentiability is given, no, so at x equals to 3, you have to check the continuity. So 3. So k root 4 is equals to what? You put 3m plus 2. So 2k is equals to 3m plus 2. This is the first equation which you are getting, continuity. Now differentiability. F dash x k, derivative of root of something is 1 upon 2 root the same thing, and this is just m. X belongs to 0 to 3, x belongs to 3 to 5. Okay, now 3 pe you need to check. So k by 2 root 4 is equals to m. So k is nothing but 4m. K is nothing but 4m. 4 to the 8. 8m is equals to 3m plus 2. So 5m is equals to 2. M is equals to 2 by 5. M is equals to 2 by 5. If m is 2 by 5, so 4 to the 8 by 5. K is 8 by 5. 2 by 5 plus 8 by 5. 10 by 5. 2, option A is absolutely correct. Okay. All right. And on this note, we have done differentiability. Now, LCD. You have to solve as many problems from LCD as possible. Okay. And the next chapter is going to be differentiation. Okay. So, be ready for differentiation. And I know that you guys are waiting. How many of you are waiting for indefinite integration? But we need to study differentiation, at least differentiation before integration. Okay. So let's see. Differentiation, I'll try to cover as early as possible, so that now we can have like immense time for integration. Integral calculus is very important. If you ask me, ma'am, differential and integral calculus, which one is having higher weightage? So I will say that integral calculus have higher weightage, but again it is very much demanding, so much to learn. Okay, so I will not say that it is low input chapter, high input chapter, high reward. If you are seeing that, so high input is also required, unlike other chapters like matrices and determinant. So I tell you, low input, high output. Vector and 3D also somewhat low input, high output, but integral calculus, it needs some effort, some hard work. Okay, chalo, bye bye, see you.